Go for it.
So, hello all, and welcome to this week's Cyber Clinic. Today we have a guest of Andrew, who is going to be doing a talk on mobile security and a load of stuff around that. So he came in last year and did a talk with us and was very, very informative. And he's hopefully going to do the same for you this year as well.
Thank you very much. So Bijou asked me to give a brief talk, and for a while I thought about what I could talk about. And mobile apps is really close to my heart, but I tried to do something where I don't need to provide a huge lot of background. So what I'm going to do is talk about the OWASP Mobile Top 10, and then I'm going to talk about some cool stuff that people have found in mobile apps recently, and then there's time at the end for any questions that any of you have. I think the guys were saying there's a chat facility, so if there's any questions, just fire away, and we'll get to them at the end of the presentation. So to get started with a brief about me slide. So as Matt mentioned, I spoke last year at the university. I graduated in 2014, so I did the Ethical Hacking for Computer Security course, which has since been rebranded, I think, to a lot like you may be doing, or some of you may be doing that degree now. I did a placement year. I did a year out staying in the Northeast, and I was an electrician for a year. That was quite cool, very interesting, and not hugely related to cyber, but was definitely worthwhile. And then since leaving university 6 years ago, I've worked in kind of cybersecurity kind of full time since then. And it kind of extends out from my day job to also in kind of in evenings and weekends. So I help run the OWASP Newcastle chapter. I'm one of the 3 chapter leads, and I've been doing that for about 3 years now. And that's free. So anyone can join, come along. Although at the moment, obviously, we're not face to face, so there's no free drinks and free pizza. It's now just all virtual. But all of our meetups that we've had during Corona have been streamed online, and it's been quite nice that people from all around the world have joined us. That's quite cool. Obviously, given the circumstances. And then the other thing that I do with security part-time is I head up or help contribute towards the Mobile Security Project. And that's the part of the organization that looks at some of the trends in mobile application security vulnerabilities. And every 3 years, we'll look back at what are the most common occurring or the most interesting vulnerabilities and try and put together a list of the top 10. And it's not necessarily in any order, but it's the 10 most prevalent common occurring vulnerabilities. In my case, I'm interested in mobile apps, so it's about mobile applications. Until about recently, I was a red teamer, so I worked in offensive security. So I was very much a hack the planet, break everything kind of guy. And I've just started to switch towards application security very recently, to the start of this month, and doing a bit more about defensive work, understanding the lifecycle journey of security, and a bit more fixing things. So the breaking things kind of I get to do on the side now outside of work, so bug bounties and things like that. So I mentioned the OWASP Mobile Top 10, and for anyone that's not aware, OWASP is the Open Web Application Security Project, and it's a not-for-profit organization founded in America in, I think, the late 90s. And the idea is that trying to secure the internet, and it started with the web, and now there's like IoT, there's like APIs, there's robots, and there's mobile apps. And mobile apps is really what I've been interested in for the last probably 12 years. 2008 probably sounds about right. And this is the 10 most kind of commonly occurring vulnerabilities. So I'm not going to talk about all 10, but I'll explain some of the ones that I find interesting. So if we go for there, they're all labeled M1 to M10. So M2, insecure data storage, is quite interesting. There's been a few talks recently about the way that applications store data. We had a talk at OWASP, in fact, this month, about the way that Snapchat and other applications store data on the device. And this is vulnerability is particularly to do with the way that information is encrypted on the device, or isn't properly protected, or can be accessed by other applications. And this is quite common. That there's a misconception that the way that information is stored on a device. I know that the government is trying to push hard against this kind of end-to-end encryption, But I don't think that end-to-end encryption is as prevalent as what people think it is. And sometimes data is leaked outside of that secure storage area. M3 I find particularly interesting because if you think about a typical web application and you go to a website and you type google.com, you've got the nice little green padlock. You know that it's secure because you've got that padlock and you get like a nice little warm feeling in it, and you know that the hackers aren't going to get you. If you think about a mobile application, you don't have that padlock, right? You don't know whether when you connect to like Starbucks Wi-Fi, if someone can sit in and man in the middle all of that traffic. There's no visual clue. There's no indicator whether you know that channel is secure and encrypted. It's becoming more and more of a thing. I think Apple have been pushing this since about 2017, 2018, trying to make it mandatory for going forward that encryption or communication happens over HTTPS. And Google for the Android platform have been trying to push a similar thing. But people always find ways around this. They won't use the official APIs or use different methods of doing things. No discredit to developers, but they do what works. And if setting up HTTP works for them, why would they ever push it over HTTPS? Integer authentication is a mechanism which is kind of seen in web applications as well. So maybe they're doing something wrong. Maybe that username password can be brute forced. Maybe they're doing something wrong around sessions, that handling that can be it's maybe a little bit immature in terms of security. Cryptography is a really weird one. I'm not a mathematician, so I don't fully pretend to understand cryptography. I think it gets a bit disservice when people say it's just maths. It's just maths, but then speed is just physics. I think there's a little bit more to it than that. But there's kind of a general rule in security, and this is that do not roll your own cryptography. Cryptography it isn't meant to be secret, right? Like the schemes in which the way that cryptography is handled and processed, that should be transparent. The way that the data goes from being plain text to being ciphertext and encrypted, that process should be transparent. Okay, maybe not the keys that are being generated, but I've seen occasions where people will just stick 6 zeros as the key, or they'll hard code the key into the mobile application, and then you can reverse engineer, pull that key out, and boom, you can decrypt all the data. So insufficient or kind of weak cryptography is quite a kind of common occurring theme in the mobile. And what's really interesting for me, at least as someone that's really super interested in mobile, is that there's just been kind of weird transition. So where things were called network security, and then information security, and then cyber security, and it's these kind of iterations of the same kind of thing, just with a new funky name on it. So what generally started to happen is that things or companies or people or developers or whoever was making these applications started to identify, with the help of OWASP and other pen testing and other things like that, identify the vulnerabilities in their code, start fixing them. And we generally tend not to see as many of these kind of vulnerabilities in web applications. However, in 2007, 2008, the iPhone came out, Android was released to the world. And all of a sudden, more so in the last few years, probably in the last 5 years, there's been a rush to market where people have said, actually, if I'm company A and my competitor company B has got a mobile application, I'm probably going to want a mobile application as well. So the latest round of developers will go, they'll release a mobile application, and there's a rush to market where I need to get this product out the door as quick as I can, as fast as possible. And security has never really been a conscious decision that developers have made until maybe 2 years ago when GDPR became a thing. But prior to that, it was never, it's almost like an engineering mindset. I used to work in engineering, and the engineering mindset is you generally need two things. You need either WD-40 or glue, right? If it's moving and it shouldn't, then it's glue. And if it's not moving, it should, and it's WD-40. And it's that kind of make things work in the easiest, quickest possible way that you can. And I don't think that's necessarily a bad thing. But when it comes to security, that definitely has implications in the way that people are building mobile applications. The remaining kind of top 10, and this top 10 is from 2016, so generally these get revised every 3 years. Due to what's going on in the world at the moment, I don't think these is going to be revised until probably end of next year. So Yeah, and again, these don't represent, just because something's M1 doesn't necessarily mean it should be fixed above M10 or M9. In fact, we'll probably fix some of the high numbers above the lower numbers, but there's no kind of order to them. That's not the way that vulnerabilities are scored. It's scored through CVSS, like a scoring system. So just because something's higher in the list doesn't mean it's it's better or worse to have as a vulnerability than others. The last three on this page, M8, M9, and M10, I found like really interesting. They almost go kind of hand in hand, especially M8 and M9. So M9 is reverse engineering. And I've talked about this in a few talks in the past, the joy I have in reverse engineering applications. So if you think that you're delivering a web application and all the code is hosted on the server, some processing happens on the server, and that code is delivered to the to the web browser. And if you need to patch or release an update, you do that, deliver that again through the web server. Like the client, the browser, or the user never sees that server-side code, so they can't reverse engineer generally. They can't understand some of the logic, and a lot of the time it's pen testing in web applications is almost like hunting in the dark. You're kind of making assumptions that if I poke this thing, this other thing is going to happen. It's going to do this thing. That's going to do this thing, and then something else is going to come out the end of it. What I really like about mobile applications, and specifically Android, is my strong suit, but I do look at iOS applications as well, is that you can reverse engineer them. So you can take the code that the developer made, the developer engineered, and reverse it back and actually look at that code. And you don't quite get exactly the same code back, but I don't think that's super important. You get back enough information to be able to look at exactly what the developer described when they created the code. And reverse engineering isn't always a problem. So if you think you've got maybe an open source application, who cares if it's reverse engineered, right? Someone could just go to GitHub and get that code directly. But if you have some kind of business logic, whether you've got some kind of secrets built into your application, if you've got maybe intellectual property, your application is part of that intellectual property, maybe you really care if your application is reverse engineered. And maybe you've got some kind of security controls inside your application that if someone could reverse engineer, they could tamper with that code, so they can make changes to it. So maybe you've got a variable that like sets, you've got a window and you set that window to secure to true. And maybe if you're able to reverse engineer the application, you can see that the variable is called window secure equals true. And maybe you can, using code tampering, turn window secure to false, re-sign the application and rerun it. And that's I'm seeing more and more of that kind of thing happening in the mobile world. And the reverse engineering kind of almost always leads to some identification of extraneous functionality. So this is the idea that if you've ever built an application, you know that you'll go through various rounds of testing, and you want to make sure that, for example, if you're logging in, you don't want to have to like type like a long complex username and long complex password. So you might just hard code one. So you might call it like dev admin, right? Because it's just for a developer, and you would hope that during the build process and the application getting released, that extra account that's built in, that's an extra backdoor, is removed, because you only just put it in there because you need to test something really quickly. You need to get it out the door, but you're going to remove it, right? You're maybe going to comment it out. You're going to you're going to completely remove it when you commit, but you forget to do that. And that's quite common, that these kind of backdoors, these jumps in functionality, these kind of weird hidden menus often. So I'll see an application where the server will tell the application what the user is allowed to do, and I can just change that request on the fly, and all of a sudden I get extra menus popping up. I get debug menus. I get information about the API that the application is calling. And that's more and more common. As I kind of move and look towards more and more applications. So the next part of my presentation, I want to talk about Hacktivity. So this is HackerOne's portal about publicly disclosed vulnerabilities. So HackerOne are a bug bounty platform, and they have a series of private and public bounties. So private is that you have to be invited into the program, and bug bounty being is that you can legally hack these companies, and as long as you tell them how you did it, you write a report, you send a video, depending on what they're wanting, and you disclose it to them ethically, they will reward you, normally financially, not always. Sometimes you may get T-shirts, or you may get invites, or you may get product releases, or you may get something other than cash. But often it's paid. But the idea being is that you don't disclose this until the company says that you can do. And sometimes companies will not disclose, and so they'll fix something silently, and you're paid for your silence and for your time, and that's perfectly normal, happy agreement. So when I thought about presenting the state of mobile application security, I thought, well, I'm going to have a look at HackerOne. Activity, this is publicly disclosed vulnerabilities. So companies with public programs that are happy to talk about the vulnerabilities that they've fixed recently, and I think that's quite a cool thing. If you look, I mean, I started uni 10 years ago, and the idea of a bug bounty, I don't even think existed as a concept, or if it did, it was it's a very small niche thing. Whereas now you've got government agencies, the NSA have a bug bounty program, NASA have a bug bounty program. You've got big corporates, Snapchat, Facebook, Twitter, companies like those will actively let you hack them as long as you stick to the rules of engagement. You disclose these vulnerabilities, and you do it in the right way, in the right time, and you don't go outside the boundaries of that program. They're more than happy for you to look at them. So if you're interested in this following my talk, if you can go on Hacktivity, I've left all the links in the slides. So I'm happy to share the slides later, or you can take a screenshot and just read the reports, because it's a place to learn and try and understand how exploits are created, or even how exploits occur. A lot of the time, it's not just a pen tester saying, or a hacker saying, I found this thing in your problem. There's normally a dialogue that goes back and forth between the developer and the hacker saying, okay, well, this is how you should fix this problem. Okay, we think we've fixed it. Can you retest? No, there's another bypass for it. It's quite a transparent, and it's quite a nice way of doing security. For me, security shouldn't be hidden. So I'm going to talk about 10 interesting to me vulnerabilities, and hopefully interesting to you, that have been publicly disclosed, that the most of which are paid, and they're all mobile focused. These are applications that have mobile apps or have some kind of mobile functionality. I thought that was pretty important for the context of this talk. So the first application, or the first vulnerability I want to talk about is Snapchat. So $15,000. So not bad for a little bit of work. I don't know how long it takes for the person to identify these kind of vulnerabilities, and that's what I find kind of what's really annoying. Is I've got friends that do bug bounties, and I do bug bounties, and whenever I read a report, I'm like, oh man, I could have found that. That's so simple, such a trivial thing, but I don't think you appreciate the time that goes into someone finding this kind of information. And information disclosure in a security report is normally pretty low. It's not normally high risk, but then in this context, they had a production Jenkins instance. So Jenkins is a way of it's part of a pipeline of deploying or creating mobile applications. So you give it a load of data, and it will you give it the code essentially, and it will do some work around the code and generate you the mobile application. And what this hacker is saying is actually this instance was production, so it's a live instance which is producing actual Snapchat mobile applications. It was on the internet. It wasn't protected. It wasn't whitelisting anyone's IPs, and I could log into it with any valid Google account. So Google, you can sign up for free, and you could then navigate to, I don't know, presumably jenkins.snapchat.com or something very similar. And then you could log in, and you could see private data that as a person on the internet you should not be able to do. So there was some information that says there about, so you could see the source code of the applications, which isn't great. You had access to API tokens, and you could probably massively change the way that these the Snapchat applications run. You could add functionality yourselves. You could probably create backdoors. Yeah, so $15,000 seems like a quite high amount, but it's probably fair. And then when I was looking at this vulnerability, I looked. There was also, I wrote these slides maybe 2 weeks ago, and then last week, as I was looking through, there was a similar vulnerability. There's a system called Grafana, which is like a graph based, so it tells you the availability of instances, how things are, how the pipeline is working, how it may give you information about the number of users that are online, things like that. And again, multiple production Grafana dashboards were available to anyone on the internet. They class that as a high-class vulnerability. It's the same as this. They awarded $10,000 because anyone with a guest user could access this kind of this instance. So I'm not necessarily picking on Snapchat. In fact, probably quite the opposite. It's quite good that they are publicly disclosing these kind of vulnerabilities. I think in the past there's been an element of like, well, we'll keep this super secret, super quiet, and no, we don't have any security problems. So it's quite nice that they're quite open about the fact that they have these problems and they're fixing them. So the next vulnerability is from a company called Instacart. So it's not a name that I've ever heard of. When I had a look, it does look like a kind of a way to provide shopping, like a shop to online customers. And I couldn't see any information about whether this was paid or not. It just looked like it was. So it might have been paid, but either the Instacart or the hacker certainly never disclosed how much was paid for this vulnerability. But it allowed, or there was a leakage of their private API key. So Instacart will have a private API which can be used by their customers or normally internally to Instacart's own staff. So information that is not public, they will lock down with an API, a private key, and they'd leak this key. Again, it doesn't say where. Feel free to visit the link and have a read about it. There wasn't a huge amount of detail I could find, but it was kind of interesting that they have a mobile application. And I think this private key was leaked in the source code of this application. So someone was able to reverse engineer the application, pull out the API key, and then access all of Instacart's private instances or API without any kind of restriction. And it kind of shows that from those 10 vulnerabilities, I've always had people come back to me and say, well, reverse engineering doesn't really matter. It's not a huge problem. And maybe it isn't, but if you're embedding private API keys, whilst that's a vulnerability in itself, if you don't appreciate the fact that people can reverse engineer your applications, you maybe don't understand the fact that this could be a risk. So post Snapchat are going to get a bit of a kick in again, I'm afraid. And this is quite a simple exploit. So cross-site scripting. So this is the idea that you can run arbitrary code, JavaScript, against an attack source, and there's two kinds of cross-site scripting: stored and reflected. So stored is the worst kind because you just have to. Stored is maybe like a profile, right? So if you have a profile and you can put cross-site scripting in your name, then all it takes is someone to visit your profile. You don't have to encourage them. They just need to, they could just be looking at a directory of names, and boom, as soon as they see your name, like some code will happen, some magic will happen, or some bad stuff will happen. Whereas reflected is actually you need to trick someone into clicking on a link, like shown in the snapchat.com/ad. But as soon as someone did that, this would allow you to redirect them. You could maybe steal a username and password for Snapchat, depending on the exploit. You could log their keys. You could do a few other things. So not particularly great. $250, quite a small amount for the type of vulnerability. But yeah, and that's because they're not filtering out those characters. So that %22, %3e, etc. That will be HTML script which is not filtered, is not being encoded, and allows an attacker to exploit that. And they said that they found 6 areas where the username isn't protected against cross-site scripting attacks. So yeah, quite interesting. It's quite a small amount considering, but then smaller impact compared to the other 2 vulnerabilities. So this I thought was really interesting. So Uber are quite well known. I think one of the biggest people that pay out on their bug bounty on HackerOne. I think they maybe paid out $100,000 for one vulnerability. And the fact that you can take over an account, I think most people, if they don't use Uber, are at least aware of that. It's a taxi sharing service and aware of how it works. And they had a passwordless sign up. So the idea is that and maybe it connects the Uber account to, if you want to use Facebook to sign in rather than create an Uber account, you could do that. But there was this endpoint, so this API endpoint you could just hit with numerous parts of data, and you could just change the password for any user as long as you knew their phone number. But given a phone number is like well, in the UK anyway, +447 for a mobile number, you could in theory just hit through every single user in the UK and just change their passwords, take over their account. You can maybe change their email address at that point, view their history. You could take over their account and delete it, see where they've been, find interesting information about them. So that was $10,000, which, yeah, I think that's pretty high. Again, doesn't look super complex to identify and exploit. I mean, part of the problem is when I look at these vulnerabilities is that I don't know if it's something that I would test. I mean, you almost make an assumption that like a company the size of Uber that's been going on for so long that like they haven't been. You would think that like within the last year or so that people would try things like this. Yeah, so it's interesting that that was a successful exploit. And taking over people's accounts I always find super interesting as an attack vector. The fact that you didn't have to sign up yourself. You can just attack anyone else's accounts, and you can enumerate those accounts because you can use +447 because you know phone numbers. You could automate the hell out of this, right? And you could just sit there and let it go through the whole, spin up a few EC2 instances. Wouldn't take too long to take over every single UK account, probably a couple hours. So Grab is not a company I'd heard of, but they offer a mobile application, and this is a bit of a weird vulnerability. And again, it's $7,500. So we saw that the Snapchat cross-site scripting that was reflected, and this is almost a reflected cross-site scripting attack, but it's $7,500. So I'm not sure why the disparity, but yeah. So for context, DeepLink is if you go to a website and it has a phone number sometimes, and you click on that phone number on a mobile device, it'll bring up the the phone dialer, and it'll all have the number preloaded. And that's because you can do things like instead of typing putting HTTPS in your link, you can put tel:// and then the phone number, and it will preload the app which is linked to the tel directive URI, and then preload that number. So you can have things like Snapchat might have one where they'll let you add someone if you open a Snapchat link. So deep linking is a way that mobile applications can register certain actions with them. So as soon as you open a website with that deep link, boom, that action happens on the mobile device. And there was a vulnerability in Grab's deep linking, which meant that the same exploit, cross-site scripting, could be used to open up a website, web view. So that's just essentially a version of Chrome on a mobile app device, and then that would contain sensitive information. And again, if you want to read more, there's a link at the bottom there. It explains a little bit more about how that works. Often, a lot of these times, once they've been fixed and publicly disclosed, the hacker will have included a video about how the attack actually works. So it's quite interesting watching. I think there's that saying, pictures worth 1,000 words. And I think definitely when you're trying to convey things, sometimes being able to see an attack actually happen in real time and understand how it's happening, how easy it is to exploit, makes a huge difference. So I'm going to go on to the sixth vulnerability. So I am hugely interested in banking. I used to work for a bank prior to my current role. So I've seen how mobile applications can be built for banking and how they can be used for good. So I used to work for Starling, for example, and we had a way of sending very quick payments between one user and another user just by knowing their phone number. And in fact, you were both Starling users. So I understand that how brilliant mobile banking can be. But then this is pretty weird. So RAZER, not a bank I'd ever heard of a financial system anyway that I'd ever heard of. But this struck me as quite weird. $1,000, so not a huge amount of money, but not insignificant. But the fact that you could just delete any other user you wanted at random. So the way that this works is there is an API endpoint called delete, and you provide some details about the user you want to delete. And what will normally happen is it will verify that you are the user that that's requesting a delete, so that we'll have an authorization check. and then it will just allow you, and it'll say, okay, fine, this token is allowed to delete this user, go for it. What Razor Pay were doing, where they were not validating that user that was being asked to delete was coming from the user. So it would allow me to delete, I don't know, John's bank account, Craig's bank account, anyone's I wanted. So $1,000 seems quite small. Might be quite, I don't know, denial of service. I always wonder. I know that it's part of the confidentiality, integrity, availability. So the A of the part of that CIA triad of security. But yeah, $1,000 for deleting someone's pay system. Yeah, that's quite cool. Quite interesting from a security point of view to find something like that. And a lot of these times, if you go to the reports, you can see how quickly a vulnerability is turned around. So maybe it's raised, at 9 o'clock on a Monday morning by a hacker, and you'll see a variance in the time it takes for the company to respond, to say, okay, we're looking at your vulnerability. 2, how long it's taken to triage that vulnerability. Once it's triaged and the company's happy with it, they'll then pay the hacker, and then they'll then look at fixing it. And then once they fixed it, there will then be a period of time before they publicly disclose it. And it's quite interesting to see the variance between companies and how long it takes one company to disclose a vulnerability versus another. Curve is a company that I know very well. It's one that I use, and they are similar to fintech banks. But Curve's proposition is that it's all mobile, but you have one card and you can link all your other cards to that one card. So you don't need to take one card out with you when you go shopping. And if you want to charge it to your credit card, you press a button and it charges it to your credit card. You want to charge it to your your joint account or your normal account, press another button inside the app, and you can change it to another card. So quite cool. You can go back if you've charged the wrong card and correct it. It's quite a nice little functionality. But they were disclosing information about their users. So, for example, it's kind of similar to the previous one where you have a list of information and like similar to the Uber one where you have phone numbers identifying a user. And what this would do is you could say, okay, I want to register, and a request will be made to the registration server with an email address, and then it gives you back the information you've entered. But what you could do is if you knew someone else's email address, you could send that request, and if they'd already registered, it would give you information back. So it would give you their name, their email address, their phone number. Well, you know their email address because you need that. So the name, their phone number, their zip code, and their position in the queue, which isn't super sensitive, but it's mildly interesting. I guess you could use that for another form of attack. And this was just for the US launch, but really interesting the fact that this huge information disclosure, $1,500. I think it's quite a low amount considering you're getting people's names and phone numbers. I'm not sure how the ICO would, if this was a vulnerability that went live outside of a bug bounty, I don't think that'd be particularly seen on, pretty well. Number 8, ZENLY, again, another company that I'd not heard of, but again, similar to one of the other vulnerabilities where $750, quite a small amount, but then quite a small amount of work. And again, back to this reverse engineering idea. So if you reverse engineer the application and the developers haven't obfuscated their API tokens, someone can just see the API token, pull it out, and do something. And this was actually their analytics token that was inside. So what a lot of companies will do, they'll build a mobile application and they'll want to know user journey. So let's say you're a bank and you've got 10 sign up steps. How many people are going all the way through to 10, and how many people are going, actually, I get to step 4 and I can't be bothered. This is too much of a process. They'll collect some kind of analytics about that. And then also when an application crashes, they will try and collect information about what device the user has. Are they connected to Wi-Fi, 4G? Maybe they have no signal. Maybe they're out of storage on the device. They'll try and collect information about why the application crashed, and then send that to the developer so that they can actually look and go, okay, this was a problem. Maybe we need to add some more error checking into our code or something like that. So what this hacker way to do was to take the API token, and could send loads of requests back. So it's not super interesting as an attack, I guess. I mean, that's kind of where it says polluting someone else's data while possible isn't profitable, because you're just going to fill a database with noise and with rubbish. But mildly interesting nonetheless. And for a small amount of effort, you could probably automate this. $750, not a bad, for a couple hours work. So the next one is Twitter. Again, whether if you've certainly not used Twitter, you've probably at least heard of it. And this is a vulnerability that directly affected just the Android application. It's a bit of a weird thing. I'm not sure how this came about. Like, this seems like a really weird bug to find. But if you on Twitter, you can set your profile to private so that only people that are following you can see your tweets. So, if you want to protect it, make sure that, people you don't want snooping on you don't see your tweets, that's fine. And there's this really weird bug that if you change your email address, as soon as you change your email address and verified that email address, it would unset your protected tweets, which is really weird, odd functionality. And I'm not even sure how that you would expect that to happen. And it's not necessarily something I would test for or would think about testing. I guess this attacker probably saw it by chance. They went through this functionality, probably protected their tweets and discovered the fact that it was just unprotected. $3,000 or just short of $3,000. I think that's quite a good amount for what's a weird and unique bug. And kind of security and privacy kind of go very closely hand in hand. And it just kind of proves that we've talked about Snapchat, talked about Uber, talked about Twitter. These are big companies with big development teams, big amounts of pocket. So they've probably got a really good secure development lifecycle process. They've probably got a big security team. They're probably doing some kind of pen testing, and they now put this out to bug bounty. And these apps probably made it through all the first 3 processes, and yet people are still finding quirky and unusual bugs like this. It's kind of proves that you can't just throw money at the problem, and that even companies that are trying really hard, to get things right, still mess up every now and again. And it just proves that no one's perfect, I guess. And the last vulnerability I want to talk about again, it's kind of a weird glitchy bug, and it's a company called Shopify. Again, they provide a storefront. So if you, want to sell things and you want to very quickly build a shop and sell things online, you can use their functionality and just bolt the Shopify technology on. $500, so not a significant amount of money, but it's kind of a weird attack. So you generally need physical access to the device, but if someone has that, it says there, someone has the fingerprint option on, you can send someone a deep link, via an email or like onto a website, and then boom, all of a sudden they don't need to log in. If you had physical access to the device, you could bypass that fingerprint restriction, log in and see whatever they're doing on the Shopify, maybe change the bank details so it's you that gets paid instead of them. And this can also be done using, there's a tool called ADB, which is just a tool you can put on your laptop, and you can do it using this as well. So you don't need to get someone to click a link. If you found an unlocked device and for some reason Shopify's got a biometric password, like a fingerprint on it, you could connect your phone, the stolen phone or the phone that you found, the victim's phone, to your laptop, run a command using ADB, and it would bypass that activity and therefore get you into the settings of the application. So like a really weird bug, kind of often requiring physical access, which is probably why it's only $500, but quite cool at the same time. So thank you very much for listening. I thought hopefully that was interesting. Security, like mobile security, definitely is an area which is I'm super keen on, and I try and show as much information about that as I possibly can. I don't know if anyone's got any questions now, and I'm happy to answer them. Or I'm on Twitter, which is the middle. You can email me, or I'm also on LinkedIn.
Yeah, we've had a few questions come in.
Cool.
How do I know if the mobile app is safe?
You kind of don't, and I think that's part of the problem. So again, there isn't kind of a de facto standard. I think it's part. So Google do some stuff and Apple do some stuff when the apps go into the prospective app stores. They'll check for some things. I mean, it's all contextual. I think one of the things I've talked about previously in another talk is about permissions. So one of the things I'll look for is like, is an app got like loads of permissions? There is an element of trust, but also there is segmentation. So hopefully, even if your app is bad, you would hope that other good apps. So like, let's say you've got a rogue app that pretends to be something else. You would hope that your banking application is built in a way that it can't be attacked by other applications. And I know it's a bit of like a get out of jail card, but there kind of isn't a de facto standard for like this application is good. And I think part of the problem is that version 1.1 might be secure and some bug might be introduced in version 1.2, and then version 1.3 might be, secure again. I think security is like that ever-moving goal post almost, and just because something's secure today, it might not be secure tomorrow. So I kind of almost avoided that question, but there isn't a way, unfortunately.
I've got a couple more.
When you were talking about permissions there, if you're on Android, there's an excellent app called Paranoid for anyone just in the chat that wants to go away and check what apps have permission on their own phone. Just as another thing, but we have other questions as well. The next one here is, if an app is safe, we don't have to worry about it. You've just answered that. If it's safe today, it might not be safe tomorrow. So yeah, exactly. And developers aren't making these kind of I would put good faith into developers, right? They're not doing these things on purpose. Sometimes they rely on someone else's code or a dependency or a library, and that library becomes vulnerable, and therefore even something that they've had no control over whatsoever can make their app insecure. So I do feel like the pain of developers when they're told they've got to write quick, fast, efficient, clean, beautiful code. Oh, and can you do security, which is a full-time job in there as well? It's certainly not easy. Have steps like, do you know of some good apps that have anti sort of like backdoor and reverse engineering stuff in it? Are there any apps that stand out to you that are better than the rest for that kind of stuff?
So I can only speak about one that I have a lot of experience with, and that's Starling Bank, because I helped write some of the anti-reverse engineering stuff in that. So if anyone's super keen on like understanding what a good mobile application looks like, maybe you don't need to sign up, just download the application and have a look at the reverse engineering. So it's hugely obfuscated. It will look to see whether your device is jailbroken or rooted. It will hide some of the methods for the application. So normally you'll have like a classes file and all the code will be in there. Some of it will be obfuscated and hidden away in other areas of the application. It'll look for emulators. It will look for dodgy versions of the operating system. It will do a lot. It's like kind of defense in depth model of like doing very, very many security things in the hope that one of them triggers the device to go, or the application to go, this is an insecure device, and just stop working. That's the I think bank, because it's people's money, care more. There was kind of a bit of a running joke at Starling that we were like, well, this isn't Snapchat, this is people's money, and we need to build a secure app. And I think, like, despite the fact that I've kind of picked on Snapchat a little bit today, I think that kind of rings true. When it comes to money, people's money, even the regulators get super paranoid. So any kind of financial applications, I would normally expect that they're hardened more than other applications.
Just going off a little bit more about that, like me personally, I've rooted my phone. I'm not doing anything malicious with it, but I just wanted better battery life. So if I was using Starling's app, would it completely stop me signing up, or would it just limit the methods, or how does that, if you can talk about that kind of stuff, because I know some of it might be a little private and stuff like that.
Yeah, so these are my opinions. I don't work for Starling anymore, and these don't reflect my current employer. Obviously, there's my get out free card, so I don't get sued. But so routing is normally done with the best intention. So it's things like underclocking the CPU, so you have larger battery life. But what it does mean is that malware can try and get that root access and therefore break some of the security controls that are inside Android or iOS operating, or if it's jailbroken iOS operating system, and could, in theory, I mean, this is like, if things line up, could in theory break the protections in place and therefore maybe steal money out of your account. Now, I know like a few things need to line up for that to happen, but from a regulator's point of view, it's safer if they don't allow jailbroken devices or rooted devices. So, for example, some banks, like I haven't looked at Monzo's for about 2 years, but Monzo, I used to have a rooted Android device, would run absolutely fine on Monzo's. Whereas I know Barclays, I mentioned Starling just because I have first-hand knowledge, but Barclays would blacklist your device. So even if you, there's a device ID attached to the device, and even if you unrooted your device and factory reset it so it was back to stock, Barclays would not let you download that, run their application on that device ever again. I don't know if they've changed that in the last 2 years. It's been a while since I looked at them, but essentially no. Some banks you'll get a warning, some banks you'll get no warning and it'll just run, and some banks will not let you run because the perceived risk is that you could lose money, and if you lose money as a result of that, where do they point the liability? Is it you or is it the banks? And I think the regulators and the banks are having a bit of a pointing session, and the banks, at the moment, certainly don't want to accept that liability.
Yeah, that makes a lot of sense because someone in the chat has also said Barclays had issues with routing just like literally maybe 5 seconds before you said it. So yeah, that's obviously still an issue. Patrick's got one here that is apps have started, like iOS has started telling you when apps have access to clipboard. What other policies would you believe that should be implemented into either iOS or Android to have better idea for the mainstream on their own security, if that makes sense? So what would you implement in operating systems to make the everyday layman's person more understandable about the security of their device?
I don't know whether it's a legitimate concern, but there was a device, I think it might be an Oppo phone, and it had a camera which was like mechanized. So the camera was hidden in the body of the device, and then it will pop up and take a picture. And I was like, well, that's quite cool because I know that the camera is being used. I mean, maybe I'm super paranoid, and maybe that's why I work in security in the first place. But I don't like the idea of like me just using my phone and then like there's some picture of me taken without my knowledge. So I know that there's third-party apps that tell you when the camera is being used for both iOS and Android, something like that. I think it's really difficult. Like, I'm not sure that there's one kind of easy fix, and some of this, like, I would like to see more emphasis put on the development lifecycle, and so that hopefully the vulnerabilities don't get to production. I think that Google should mandate that code is obfuscated. It would make my life as a hacker much harder. And if you're building an Android device, you just tick a box and obfuscates code immediately. It's not going to stop a determined attacker, but the way that I see security is that if you've got 10 cars parked in a car park and one of them hasn't locked the doors, well, unless someone's really determined to nick that Ferrari in the corner, an attacker will just steal the easiest car, right? And for me, if you're obfuscating code, it just makes it more and more difficult. For a user, I'm not sure there's anything we could do. It's a good question though, and probably something I should probably think about. People have asked me before, like, can you build a list of like good or safe applications? And it's like, well, it kind of goes back to what I mentioned earlier. Well, I could build version numbers, I guess, but that doesn't necessarily mean they're secure. It means that on the day I tested
vulnerability.
On the day I tested them at that exact time, based on the amount of time I spent on the application, I think it might be secure, and that's like a lot of variables. So, yeah, Google and Apple are doing good things. They are like Apple pushing HTTPS heavily, and Google now following that. Apple heavily making sure that people only use or try to force people to use their official APIs is quite good. Yeah, I think the developers need to do a little bit more on their end rather than yeah, I'm not sure we can do what we can do to protect the user more.
Thank you. That answered my question for that anyway. Hope it answered Patrick's as well. Is data encrypted everywhere and wherever it is on a smartphone, or does it depend?
It depends. So this is it's a worse state of affairs sometimes on Android. On Android, you can have SD cards. So you then have external storage, which is probably never encrypted. At rest, at least Android allows full encryption. So like the typical way that you see a disk encryption, full disk encryption on a laptop, Android, depending on the version, has full disk encryption and file-based encryption for quite a long time now. But then if the device is running, if it's unlocked, a database can often not be encrypted. So the way that Android apps work is that they have a database sat behind them. So if they want to store data, and there is a really like easy way of getting that database encrypted. Like it's a native thing for the developer to do, but it's easier not to make it encrypted, right? If you want data out of the database, so let's not make it encrypted. So it depends how good that the app's been developed, and if you're using an SD card, and yeah, whether that functionality has been implemented. On iOS, I think it's a very similar state of affairs that you can encrypt the databases. They're normally SQLite databases, but iOS doesn't quite have full disk encryption, which is something I learned last week. iOS is a little bit of a weak point of mine. I've not looked at devices for quite a while. Yeah, so not to slide the question, but it depends. It's probably the easiest way to answer that question.
And if you're running an older phone, or an older operating system on your phone, it's probably less likely that, again, it is encrypted as compared to a brand new device.
Yeah, yeah, and sometimes why people root the devices, because let's take like Samsung support devices for like 2.5, 3 years. Some people keep devices for like 5 or 6 years. It's not unheard of. So they stop receiving security patches. So third-party people will release like operating systems, which is based on Android, and they will then release security patches. So there is an irony in that there's a perception that rooted devices are often weaker, when actually someone might be running something like Lineage OS, because they then continue to get security patches. Yeah, so ultimately, if a device is older, it's probably more vulnerable to more attacks. I guess is probably an easy way of describing that scenario.
Thank you. We got one more, but and then I think it's sort of like that's all the current questions that we've got.
Cool.
If your phone runs out of battery faster than ordinary, is that a way that someone has hacked you, or is that a sign that someone has hacked you?
I mean, it certainly could be. I'm not saying it definitely is, but it certainly could be. There's been like how we've seen the kind of ransomware type stuff on attacks recently, like Garmin for last year, for instance. Like there has been ransomware attacks on devices, so it could be that your CPU is being utilized more. Something I always do is go to the settings and look at battery, and just look at to see what applications are using the battery more. And if every day it's like a different app, then maybe that's normal. But if every day, if I don't know, like a weird app that you've downloaded is using more and more of your battery, that's probably not a good sign. There is like Bitcoin miners for that can be built into Android applications now, so that's going to use a lot of battery, a lot of CPU. So it's not a definitive sign, but it's maybe not necessarily something to be super cautious of, unless your battery used to last like a full day and now it's lasting like half a day. Then I'll be looking at the battery statistics to see what apps are using them, for sure.
Perfect. Thank you very much. Ryan, have you got anything else to ask?
That was brilliant.
I did really enjoy that, yeah.
No worries, thanks very much. And I'll share these slides around
Yep.
with you guys, Matt and Ryan, and you can feel free to pass them out afterwards.
Yeah, cool.
Perfect. Thank you very much. So everyone, that was Andrew. He was doing the talk on iOS security and Android security, and about bug bounty programs and some of the most common stuff that's out there. We're now going to be nipping over to the Discord to do hopefully some live demos of some attacks and some full virtual machines we're going to be trying to get into.
Yeah, I'm going to be having a crack at one of the Hack the Box machines, see how far I get in like an hour and a bit. Feel free to jump over and come have a chat and stuff.
We've purposely not had a look at this challenge before, so that we can show you the full process instead of telling you exactly where each vulnerability is and just demonstrating them. This is going to be the full process of if you are looking at a completely blank system and to have a go like that. So unless anyone else has any more questions, we're going to be jumping over to the Discord. Thank you very much again, Andrew.
Thanks very much. Thanks everyone for your questions. It's been great.